Hello, period 6. We're here for you today because we're going to be in a pep rally this afternoon. Okay. So anyways, my goal is to go through the test from Wednesday and from last Friday with you today, so you get some feedback on that, see how you did. We'll talk about that briefly. If I have time at the end of the period, and I'm really pushing to have time at the end of the period, I want to show you how to make a graph with Excel very quickly and easily. Just hang on till the end of the period, and we'll go from there. So the next thing I'm going to pass back is the math part of the test from Wednesday. Please don't talk, because I do have the camera rolling, and they'll make fun of you if they hear your voices. Just kidding. Hopefully not. Nice order this was had a wide variety. This class, by the way, had some killer scores, and I mean good ones. Okay, there was some killer scores in the other direction too. But let me leave this with you. I'm not going to spend a lot more time talking about this after today, but we will be using this procedure all year long. If you have not mastered this, it will hurt you all year long. Okay, and I can't emphasize this enough. And I'm kind of almost at the end of my rope with help classes and trying to drill this into you. These 10 people over here have mastered this process, and I would suggest you get with one of them and get some help, or get some help from me. If you're too proud to come see Mr. Debski, then talk to Alex, Jacob Fettner, Victoria Foster, Chastity Howard. 4 of those are in this class. Heather Lawley, Katie McGarity, Maddie Overstreet, Russell Person. 5 of them are in this class. Peyton Rickett, Christiana Taylor. 6 of them are in this class, and they have aced this thing. They have mastered this process to every tiny little detail. Okay? And so that's who you want to get some help from if you're too proud to come see me for help class. But don't just let it ride for the rest of the year, because in a month or so, or Christmas time, or January, you are going to lose oodles of points on tests because you don't know how to do this. Okay? So let's go through this. I'm going to show you what the answers should look like. I consulted them this morning on my smartboard here. And number 1, it was a conversion problem, so there's really no formula to use. We start with 12 ounces, change it to cups, change it to quarts, change it to milliliters. If anybody struggled with this one, was this last step, how do I get a deciliter? Well, I go over to my King Henry and go, King Henry, drink chocolate milk. I use this one, 100 milliliters in a deciliter, but you can also change this to 1,000 milliliters per liter, but then you're going to have to go back and do it 2 steps and change 10 deciliters per liter. Anyways, this works the best way and the shortest way. Answer is 3.55 deciliters. Done. Short, sweet. Number 2. And guys, really, I gave you the whole period, but that shouldn't take you more than 2 minutes, seriously, to line up these conversion factors and cancel them out. The units, the reason it's called dimensional analysis is because the units tell you how to set up the problem. If the units don't cancel out, you got something wrong, or something's upside down, or something's not going to work. But the units are literally, sometimes when I solve a problem like this, I write all the units in, and then I come back and fill in what all the conversion factors are from the King Henry or from the given numbers or whatever. I start with ounces. I got to have ounces down here. Okay, ounces per cup, then I got to have cups down here. Cups per quart, then I got to have quarts down here. And literally set up your units so that they cancel out, and then fill in the conversion factors. Number 2, okay, we're looking for volume in cubic feet. We're given a density in kilograms per liter and a mass in tons. Okay, so the goal here is to reconcile the kilograms and the tons. Now, if you do this conversion from tons to kilograms, I have to be able to find it. Okay, and seriously, I spent 6 to 7 hours grading just those, okay? Just those little things. Wednesday night until very late, Thursday morning, bright and early, like 5 a.m. until 7 a.m. And they take me 5 to 8 minutes apiece to grade those. So I'm trying to give you partial credit, guys, okay? 1.22 tons, here's the best place to put it. If you write this down as a variable, then here's the best place to convert it to kilograms. Don't put it somewhere else on the page where Mr. Debski will never find it. And definitely make sure if you do, it's labeled like with units and stuff, because a bunch of numbers on a piece of paper doesn't help me, and it doesn't help you. 1.22 tons, 2,000 pounds per ton, 454 grams per pound, 1 kilogram per 1,000 grams. Notice that all my units cancel out: tons, tons, pounds, pounds, kilograms, grams. Kilograms is what's left over. Yay, that's going to cancel out with this once I put it in my density formula. V equals M over rho. Still got 2 or 3 people per class struggling with the algebra thing. You need to master that soon. If I wrote on your paper SIGs, that means you messed up the sig figs on your final answer. If I wrote on your paper, I've got some code words here somewhere. If I wrote help class, that means you need to go back and watch the videos from Monday and Tuesday, do some problems from the back side of the review problems, and then come see me for help class. If I wrote the word bad math, that means it looks like you did everything right, and then you get the wrong answer here, which usually is a calculator problem. So bad math, I just can't figure out where you made the error, probably punching numbers into the calculator. If I wrote the word steps on your paper, that's because there's a bunch of numbers and no steps in the procedure that I taught you on how to solve these problems. Okay? And I had something written down here which I'm not sure what it means. No sub. I think you didn't substitute numbers into the equation or something like that. Anyways, once I get this formula here, I can substitute my mass in kilograms and my density in kilograms per liter. That gives me liters. This is the hard part of the problem. A lot of you struggle with getting liters into cubic feet. Okay? So I go from liters to cubic centimeters. That's not too tough. But then how do I get cubic centimeters to cubic feet? 2 conversion factors, but you have to cube both of these conversion factors. So that means it's going to be 1 divided by 2.54 3 times, and 1 divided by 12 3 times. Okay, if you only put it there once, or you don't divide by this 2.54 cubed or 12 cubed, then you don't have cubic feet. You've got some abomination or units between centimeters cubed and inches and feet and stuff like that. So some of you had the right idea, just didn't quite get all those conversion factors in there. Final answer, 2 sig figs, 44 cubic feet. The sig figs are controlled by this one right here. 2 sig figs and 3 sig figs. Questions here? Okay, it's a density problem. We've been doing density problems for 2 weeks now. Okay, here's another one. This is a velocity problem. So time in hours or seconds. I think it said seconds, so that might actually be wrong up there. Distance is given as 222,000 miles. Velocity is in meters per second, so we have to reconcile meters with miles. Okay, we've done problems like this in class, in bell work, for homework, plenty of times. So again, there's nothing new here. 1.6 kilometers per mile, 1,000 meters per kilometer gives me this really big number, 355,200,000 or something like that meters. Once I do that, I write my formula down. Okay, then I solve it for t. Substitute. Here's my substitution. Meters divided by meters per second is going to give me seconds. And then I need to change that into hours. No, it wasn't hours. Yeah, this one wasn't hours. Yeah. It's a different problem. It was a microsecond one I'm thinking of. 28,400 seconds, 1 minute per 60 seconds, 1 hour per 60 minutes. Gives me 7.89 hours. Got to be 3 sig figs because both of these are 3 sig figs. 3 sig figs, 3 sig figs, 3 sig figs down there. Questions here? Okay, next question. Number 4 is an acceleration problem. You say, I thought it said deceleration. Guys, the word decelerate just means negative acceleration, okay? Deceleration is when your final velocity is less than your initial velocity. That's slamming the brakes on in your car. You are decelerating, which just means slowing down. It's a negative acceleration. So I'm using the same formula and the same variable. A is acceleration, whether it's negative or positive. Meters per second squared, velocity 1, velocity 2, and the time, okay? Now, some of you are really smart, not like me. I did this out twice, so I didn't copy it here, but I'm going to use exactly the same steps for both of these to change them into meters per second. Some of you were so smart, you subtracted the two numbers first, and then you only did the conversion once, which was a really smart idea. I should have done that myself. The other thing some of you did was you changed, there was some interesting solutions to this problem. Very unique, very creative, that weren't exactly like this. And again, there are multiple ways of doing this as long as all the units end up working out in the end. So I got these 2 meters per second. I substitute them in here for my delta V, initial minus final. I divide by my time, 3.001 seconds. Oops, getting a little sloppy on my units here. And meters per second divided by seconds is going to give me meters per second squared, 2.67 to be exact, because I've got 3 sig figs, 3 sig figs, and 4 sig figs. So 3 sig figs would be the controlling one here, 2.67 meters per second squared. Questions here? Okay, number 5. Number 5 was the only one that might have been a little bit foreign as far as the formula goes, but again, from a standpoint of solving the problem, it's the same steps over and over again. What are we looking for? We're looking for time in seconds, microseconds actually. I think this is the microsecond one. Giving you energy in calories and power in horsepower. And then I gave you the 2 conversion factors. Now, some of you used the wrong conversion factor on the wrong number. Again, you can't do that if you set it up and look at the units. Calories have to cancel out with calories. So 400 times 4,184 is this many joules. Joules is energy. 1.33 horsepower. Who cares what a horsepower is? I've given you the conversion factor to change it to joules per second, which is a watt, by the way. But, so the horsepower cancel out and change to joules per second. 754.7 times 1.33 equals this number of joules per second. The formula I've given you as well in this problem, P equals E over T. You need to solve it for T. So you get energy divided by power. And some of you got this upside down. You need the algebra help. And some of you substituted the numbers in for the wrong letters. And again, the units are going to tell you you did that wrong. If you try and take joules per second and divide by joules, you're going to get units of 1 over seconds, okay, which is an electrical term for frequency called hertz. Okay, 1 over seconds is not the same as a second. Something in the denominator is not the same as something in the numerator, even with your units. And so as soon as you see that, you say, yeah, the joules cancel out, good. And I got seconds, that's the same as a second. No, it's not. That is a per second, and that tells you, oh, I messed this up big time, okay? I got something upside down in my units here, which either means you swap these 2 numbers or you've got your formula upside down, one of the 2. You substitute the 2 numbers, you get an answer here in seconds. I left a lot of sig figs here because I know I'm going to round it off when I get to the end. I still have to change it into microseconds. Some of you did the first step and left it as milliseconds, forgot to change it to microseconds. Okay, don't forget we have seconds, deciseconds, centiseconds, milliseconds, and then another 1,000 to get to microseconds. So micro is not a milli. Some of you overlooked that fact. So it's 1,000 milliseconds per second and 1,000 microseconds per millisecond, and we get microseconds. 10 to the 6th times this number gives me a really big number, and then I'm going to round it off to 1 sig fig. So 2 times 10 to the 9th microseconds. This is probably the most challenging of the 5, but again, very doable if you follow the steps. Which steps? The ones that were on the piece of paper that were on your desk. Oh yeah, you could use that. I forgot about that. Guys, you had everything on your desk at your disposal, okay? So that's what we got. Questions here? Pass those to the back, please. Yes. Yes, see me after class if you have a question about yours. I'll be glad to talk to you specifically about that. Yes. Thank you, Taylor Blackman's homework. Okay, let me have your attention up here. We're going to go through the rest of the test quickly. We found some errors already this morning, so that's worth a couple points. save that. Okay, number one, for some reason, some of my smart students struggle with true-false questions. And I don't know if that's because you doubt yourself or you overthink these things, okay? Best fit line. Best fit line is a best fit line. It's not a perfect fit line, it's a best fit line. When I draw this line through these points over here, it's not going to touch every point, okay? That's the way a best fit line works. We covered when we talked about graphing. Some points will be a little bit below, some points will be a little above. Make sure this weekend when you're working on your graph for your lab report, it is a best fit line. I don't want to see you connect the dots. It should not go. There's no way a density does that. Density is a constant physical property, so it has to be a straight line. And that is a best fit line. Therefore, this is false. So for graph, most commonly used when parts of the whole, true. Reading a measurement scale, every value is known but for certain, but no more. False. The last digit is always uncertain, which is why we talk about sig figs. For instance, in yesterday's lab, if you were measuring a graduated cylinder and it was in between 41 and 42, you could write 41.5. Okay? Say, do I know it's 0.5? There's no little lines for 0.5. No, but it's between 41 and 42. So my last digit is my significant digit. It's the last digit that I'm going to guesstimate at. Okay? And we covered that in class. It's in your textbook as well, and that is the whole basis of sig figs. Your last digit has a little bit of uncertainty to it. Volume is equivalent to a meter cubed? No. Volume is equivalent to a decimeter cubed. Or if you remember, there's 1,000 liters in 1 meter cubed, so this is definitely false. Line graphs, dependent. Dependent is always going to be on your y-axis. Independent is always going to be on your x-axis. So this one is also false. Okay, this one here, the percentages should be a circle graph, and I believe I marked that one wrong because my key here says it's a bar graph, so I think that's 2 points for everybody, or most everybody. What kind of graph would be best to use with these? None of the above, okay? This is garbage, okay? You can't graph something with people's names like, that's weird. There's nothing numerical about this, so you can't graph it, right? I mean, graphs are for data, right? And there's nothing here to tell me anything about Maria, James, Tyler, Ashley, or Daniel. It doesn't tell me how old they are, it doesn't tell me how much money they have in the bank. It doesn't tell me anything. There's no way I can graph that, okay? So that is a none of the above. This one here probably, and I'm trying to remember what this one, I would probably go with a bar graph on this one because I have 4 or 5 specific experiments. This is a beaker of water with salt in it. This is a beaker of water with salt in it. It's not a continuous process, okay? So I would avoid the line graph unless I have a continuous process. I'm trying to connect those. I have 5 separate experiments going on here with a different amount of salt in each one. Bar graph is probably the best. By the way, you can blow this up on your Chromebooks. Somebody was surprised last period you could do that. Just take your 2 fingers and go like that on the touchpad, right? And it'll make it big. So you can do this. 51, 52, 53, 54, 55. It's in between 51 and 52. So you got to be 51.8. Going to do the same thing on this one, and actually if you count these out, you'll catch your mistake like I did last period. 30.1, 30.2, 30.3. If you do that, you're going to get all the way up to 31. Whoops, I'm counting wrong, okay? This is 30.01, 30.02, 30.03, 30.04, 30.05. So this is in between 30.04 and 30.05, which means this is the only possible answer. Down here. 30.046. Okay, all these other numbers would be way over there. 30.4 is like over here. 30.5 is way over there. And the first one, 30.5, would be exactly, would be way over there as well. Yeah, 34, well, those are big, big numbers. Whoa, let me shrink this back down here. Okay, accurate or precise? Both. This one's both, okay? 29.35, man, these are really close and they're very consistent, both accurate and precise. These ones are way off, but they're very consistent, so we would say poor accuracy, good precision. Precise but not accurate would be the best. Matching here, which kind of graphs would be used, and I'm having trouble reading these for some reason. List of how many students like each pizza type, I think. That the bar chart measurements from temperature of a lake would definitely be a line graph, I think. A list of kind of people who own car by percent would be a pie chart. And a list of masses and corresponding reaction times. I think it's a line graph. Again, I'm having trouble. Oh, there we go. That's easy. Okay, line graph, bar chart, that makes sense. Line graph and pie chart, yeah. Good. Which unit is determined? This is the second. Had that one on the quiz last week. Should look familiar. Mass per unit volume is density. Okay, this one, you're just going to take that, divide by that, and pick which number you end up with. Anybody remember what it was? Silver, yeah, 10.5. Oh yeah, 26 divided by 2.6. Ooh, do that one in your head. Cool. Which value has only 4 sig figs? 1, 2, 3, 4. Stop there. Okay, that one's got 3, that one's got 3, that one's got 3. 5.67, 5.89. You're going to subtract those and then divide by 5.67. Correct answer was 3.88. How many nanos in a kilo? Micro, nano, 1,000, 1,000. 10 to the 12th, which is a lot. Okay? A million is 10 to the 6th, a billion is 10 to the 9th, and a trillion is 10 to the 12th. Deci means 10 per base. Okay? There's 10 decis in one base. 67.3 Celsius. This one takes a little bit of work. We're going to do a quick, change it to Kelvin. We're going to add 273 to get it to Kelvin and see if that's one of these 4 answers. 273, 383, 293, 303, 340. No, don't look like that one. That's definitely not Kelvin. And so now I'm going to change this into Fahrenheit and see which one of these it is. So 67.3 times 9 divided by 5, add 32. And the answer is 153. You can also figure this one out. Yeah. These two problems here. Okay, it's 17.358 plus 3.502 plus 200. This one, you're going to have a question mark in the third decimal place after you line them up. But you're just going to add them up and drop that last decimal. The 8 and the 2 are going to round up, though. And so the correct answer would be 41.00. Only 2 of them should be that answer. Yep, good job. Okay, multiply these together and round off to 3 sig figs. That's 4 sig figs, that's 5 sig figs, that's 3 sig figs, that's 5 sig figs, that's 3 sig figs. So it's got to be that first answer. 517. How many sig figs are here? 1, 2, 3, 4, 5, 6. The last 3 are placeholders, so 6 sig figs. 1, 2, 3, 4, 5. 5 sig figs there. The first 2 are placeholders. Density 6.3 minus 4.24. You got the bottle plus the liquid minus the bottle divided by 3. So 6.3 minus 4.2 is 2.1. 2.1 divided by 3.1 is roughly 2/3, 0.67. Yep, right there. 0.67. Okay. Distance light travels. That is the definition of a meter. Extrapolation is the dangerous one. System International. Circle graph. Centi to hecta. So I got a deca, I got a hecta, I got a kilo. So to go from centi, 10, 10, 10, 10, 10 to the fourth, which is 10,000. There's 10,000 of the small ones in one of the big ones. So 10,000 centiliters in 1 hectoliter. Always small base. Gigaseconds. 8 minus 3, which is 5, divided by 5 minus 0. 5 divided by 5, I think that's 1. Okay, very cool.
Interruption. That any junior or senior that has yet to meet with Johnson that needs to please report to the theater. Any junior or senior that is not yet met with Johnson that needs to please report to the theater. Thank you.
Okay, this is 2 times 4, which is 8. 10 to the 4th times 10 to the negative 12th, which is 10 to the negative 8th. So the answer is 8 times 10 to the negative 8th. Okay, these two here, let me put this on the board. So 100 meters plus 50 centimeters. Now 50 centimeters, we got to do a quick conversion, is going to be half of a meter. But it's going to be 0.50000. It's got all those sig figs. All of these are significant because they're after the decimal place. 1, 2, 3, 4, 5. 1 kilometer is 1,000 meters. So that's going to look like this. And it's 1.0000. So all 4 of those plus this one are significant. We'll line those up and it's going to be 1100.5 question mark, question mark, question mark, question mark. So I can't put anything into that. 1100.5 meters. You're going to do the same thing with this one and get an answer that looks like 1.00120. That was a hard one. Temperature of ice. Most of you got a good job on this. You can't have a negative Kelvin because it's absolute. Absolute 0 is absolute 0. It means absolutely, absolutely 0. You can't go below absolute 0. So you'll never have a negative Kelvin. This is 0.6 grams. That should have been a slam dunk. You're going to divide by 1,000. What's that?
Can we go to the
Yeah, whatever you need to do. I have no clue what's going on. Like usual. Thank you for asking. And the bonus question was methane gas bubbles coming out of the lake over near the college there, Spring Hill Lake. It was really cool. Okay. Anybody else? Questions here? So this score, plus your 20 points from the math score, plus any bonus points, plus a very generous 10-point scale from me, ended up being your score that's in the portal. Okay. Let me find this here. Okay, pennies. Pennies from heaven. Here we go. Let me show you very quickly. You can hand draw a graph, of course, on a piece of graph paper, but it needs to be super nice and neat. Follow the 7 steps that I showed you 2 weeks ago. Suppose your data looks like this. Oh my goodness. Okay, suppose I got 12.6 and 12.4 and 12.5 and 12.5, and then I got over here 41.5. Guys, stop talking, please. 42, 43.5, 45.5, and 46. Okay, what are we doing? 2 things. If you punch these numbers into an Excel spreadsheet, you can just print that out as your data, as your collected data. Here, we're going to put this equals this, and then we're just going to add each of these to each of these. And then we're going to cut and paste that, because we're copying the formula, we're not copying the number. And over here, we're subtracting whatever your starting number was. I'm going to assume it was exactly 40. Many of you kind of OCD when it comes to measuring out quantities. So we're going to take this number minus 40, and we're going to cut and paste that. I'm going to take this whole column over here and insert it in front of this column. I'm doing that for a reason. I'm going to highlight my data. These are the two data columns that I want to graph. And I'm going to go insert. Now check this out. There is an insane number of options up here for graphs. And it's just fun to play with them. Okay? You'll find spider graphs, three-dimensional graphs, graphs that you can rotate on its axis, bar graphs, line graphs, pie charts. I mean, here's pie charts, and there's like donut charts. Who would have thought, right? And what I want you to use, if you decide to do this, and it is the best thing, do not pick line charts. Okay? Pick what's called a scatter plot. The scatter plot is going to give you the best options as far as line fitting. So under scatter plot, you can pick things like this and make it into bubbles, but don't, because that's really awkward looking. Okay? But we're going to undo that real quick here. And so I'm going to go insert. I'm going to go to scatter plot, and I'm just going to pick the first option. And it's already made this chart for me. Okay? You say, well, it doesn't have any X and Y axis titles. So I click the plus and click X and Y axis titles. And then I can click right in here, and I can put in the word. I'm going to make it bigger, by the way, so you guys can see. And in here, we'll put mass in grams. Whoops, oh, there it goes. And down here, we might put volume. Volume in milliliters. And we can highlight this text in here, go back to home, we can change the font to size 25, we can change the color to red, we can change this one, we can change the font on this one over here to Algerian, make it blue. We can change the title at the top here to density of pennies. And we can make that giant as well. Just making the sound effects better. And we can make it Arial rounded bold. A little bit. Okay, say, hey, what do I do for my line? Put that plus sign over there. Watch. Something called a trend line. Boom. Okay, it does it for you. This automatically gives you, this trend line is a best fit line, automatically. And if you click on it, you can change the color of it. You can click on these buttons. You can change these from circles to squares to triangles to little X's if you want. You can change the color of them. You can make them bigger or smaller. You can make this all kinds of cool things. And then, what's sweet about this, if you have that graph highlighted, file, print, it's going to print a one-page graph. Beautiful. In color if you want. And you just click print and you're going to get that graph out. You can customize it to no end. If you decide to put both graphs on the same graph, so you can do that. I would put pre-1982 here, post-1982 here, and I'll get two lines on the same graph. If I do that though, I need to put a key in here. So over here, we're going to click on legend, and then it'll give me a legend here. Line 1, you can make it red. Line 2, blue. Line 1 can be square blocks, and line 2 can be circles. Line 1 can be X's, and line 2 can be triangles. Whatever you want, but it puts the legend in there. You can even move where this legend goes. If you want to put it down here at the bottom instead of off to the side. You can make the graph itself wider if you want instead of that size. You can make this graph, in fact, bigger. Okay, lots of things you can do. I don't like the way that's centered. It's not, so I'm going to slide it over here. In fact, if I want to slide it down here, I can put it down here. This is so awesome. In 2 minutes or less, I have generated a beautiful graph and print it out, attach it to my lab report. And then I can print out this chart, and that would be my data. So right here, I'm just going to highlight this data, right-click, print, and instead of putting a table in a Word document, I can cut and paste that and drop it into a Word document. By the way, I can take this graph and cut and paste that into a Word document, and it comes out beautiful. Okay? I can actually take that very easily, right-click it, and save it as a JPEG. And then I can cut and paste it into a Word document if the rest of my lab report's in a Word document. And I don't want a full-page graph, I just want a half-page graph, or a third of a page graph. Very, very cool. Okay? I'm just curious. So these are some of the different graph types. It's crazy what's here. You want to make a pie chart? Cool. Three-dimensional pie charts and stuff. One click. Okay. Questions on the lab reports? Ben?
We need to have a table and the graph.
Yes. The table goes in your data section, and it's worth 5 points. The graph goes in your results section, and that's another 5 points. The data is always what you accumulate during the lab. Those are your actual numbers that you wrote down. And the results, the graph is going to be a way of looking at your data. Nobody wants to stare at a page full of numbers. Charcy?
You want 2 separate graphs, so like pre and
You can do
post?
2 separate graphs, one for pre and one for post, or you can put them like I had over here. You can have 2 lines, as long as you have a key. You can have 2 lines on the same graph. Okay. Good? Guys, stop the sound effects, okay? Questions about the lab reports? I sent out a remind this morning to show you an example of what a lab report should look like. Let's see if I can find that real quick. You'll see it when you get your phones later today. I don't remember what time I sent it out. But the file should be. This is a lab report that I wrote up last week, just an example for some students. Your cover page is going to look something like this. Again, you can change the font a little bit, but that's exactly what needs to be on there. It's on the instruction sheet I gave you yesterday. Page 1, state the problem, hypothesis, procedure. Keep it short, keep it sweet. Okay? My data, if you're working in Word or in Google Docs, you can insert a nice table. Okay? It'll do a table for you, and you can insert the information there. You'll probably have 2 tables, one for pre-1982 and one for post-1982 pennies. I shouldn't say you should. I mean, you will have 2 tables. Okay? Don't try and combine them because that would be difficult. This is also part of my data down here, observations. In this particular lab, there was a lot of observations, but again, yesterday, the pennies got wet. Yes. Here's my graph in this particular case. This one didn't use a line graph. It was using a bar graph for 5 different experiments that we did. So again, I did this in Excel, and then I cut and pasted it into my Word doc here. Here's my analysis section. On this particular one, we're talking about sources of error. I talked about the results that I should have gotten versus the results I did get. Here's my percent error that I calculated. Another source of error might have been how I used the pipette. Here's my actual percent differences that I got from what it should have been. And then my conclusion down here is about a page long as well. Now, I sent this to you just so you can get an idea of what one should look like. But at the last page, this is the rubric that I mentioned in class yesterday in the lab. And it'd be well worth your time to either print that out or keep that handy somewhere so you can look at it before you turn in your lab report. This shows you the number of points for each section and how to get the most number of points for each section. Need that column and avoid this column. Have a great weekend, guys. Great. Have a good day. Right back in front of you.